Super Lab for IOD401. Today's skill is select data from a complex data presentation. Before you get started watching today's video, you should make sure you have the IOD401 skill sheet in front of you. Once you have the skill sheet with you, you start the background information. So what is IOD401? IOD401 is a skill which requires you to be able to find and use specific data from a large single set of data. Graphs and tables on the ACT often seem very complicated, but they're not. All you need to do is carefully examine what they're trying to tell you. When you need to complete a skill like finding data in a complex data presentation, just try to pick out what you know. Spending a few seconds examining the variables being described will be well worth your while. So this is things like running through halt in your head, not necessarily writing it down, but at least halting in your head on the actual ACT will give you an idea of which variables are around, so when a question asks you, you'll be able to find. Let's take a look at the passage. This passage is probably going to have a few complicated words in it. So what's going to happen is as we read the passage together, you're going to have a pen in your hand, and you're going to be circling, highlighting, or underlining any words that you may be tripped up by or confused by in the reading that will prevent your knowledge of this work. So right now in front of you, you should just have IOD 401 and follow along as we read together so that you can circle, highlight, or underline any words that might trip you up. A group of students were investigating the properties of two unidentified enzymes. The student carefully labeled the test tubes containing the different enzymes 1 and 2. To determine the type of substrate the enzymes break down, the students added the enzymes to solutions of carbohydrates, proteins, and lipids. Over a period of 1 day, the students used a spectrometer to measure the concentration of substrate in each test tube to determine the average rate of consumption at the time. The students varied the pH of the solution environment while keeping the temperature constant at 37 degrees Celsius. All right, let's get started off with some vocab. There's probably quite a bit of vocab in here, which might trip us up. Let's go through some of these words.
Enzyme.
Enzyme. Oh. Spectrometer. And spectrometer. Substrate. Nice. Lipids. Nice. Any carbohydrates. Any other words going once? Words going twice? And our words are gone. All right, so let's get started. Remember, there's 3 different ways to learn new words. It's either defined for you in the reading of passage. You can use context clues or background information, or last but certainly not least, look it up. In the ACT, we won't have dictionaries, so we try not to do that. So let's get started with the word enzyme. Right. In this case, is enzyme defined for us in the passage? Nope, no definition there. That means that we need to then use context clues or background information to figure out what an enzyme is. Does anyone have any experience with the word enzyme or recognize what the word enzyme means? Maybe not. We haven't talked about it a lot in biology yet. Essentially, an enzyme is a type of protein that speeds up biological reactions. It is a catalyst. All right, an enzyme is a type of catalyst. All right, it's just a catalyst for biological things. All right, so if you're trying to break down that cheese you had for lunch in your pizza, there's an enzyme in your stomach that makes that happen faster. All right, you're trying to you're trying to kill the bacteria that live in your mouth with your saliva. There's actually an enzyme in your saliva that speeds up the death of bacteria that grow inside your mouth. There's even an enzyme that makes yogurt. You mix a certain enzyme with some dairy, and you make yogurt. Okay, so we have these enzymes that are completing these biological reactions. To determine the type of substrate the enzymes break down. So in this case, what are the enzymes doing to different molecules? Yeah, breaking them down. And so the substrates are just the molecule changed by the enzyme. The substrate is just a molecule changed by an enzyme. So cheese could be a substrate. The cheese from your bacteria in your mouth. could be a substrate. Or in this case, we actually have 3 different substrates that the enzymes are breaking down. What are those 3 different substrates that the enzymes are breaking down? 3 different types of them. All right, carbohydrates, talked about those a little bit before. Those are mainly like sugars or things like that. Protein, we talked about things made by the ribosome, food-type protein. Now, lipid is the scientific term. Does anyone know what the lipid is the scientific term for? Lipids are what make up fats. All right, lipids are molecules that have funny looking heads on them like this and 3 tails, or sometimes 2 tails. Depending on there, kind of look like weird squid. Good. Okay. Last but not least, a spectrometer. All right, a spectrometer is a tool. All right, whenever you see something that ends in meter, it's going to measure something. All right. Spectro actually refers to light. All right, the light spectrum. All right, so essentially what it is a light meter. All right, and what can a spectrometer do? The passage actually tells you what a spectrometer can do.
It measures the concentration of some
Nice. All right, tells you how much stuff is in there. That's it. So now let's think about this experiment a little bit more in terms of the data. This is a lot of data. The reason it's a complex data table is because there's more than 4 variables. All right, what are the variables? Well, let's get a little practice on this. What I want you to do is jump down to the bottom of the page, and in your teams, I want you to halt the table. But in this case, it's a table, so we're not halting, we're holding. All right, remember, instead of A for axis labels, you're doing V for variables. The variables are whatever the headings of either the columns or the rows are. Okay, so, if you're watching this at home, you want to pause right now and hold table 1. Fill out the blanks, press play when you're ready to go through, right? If you are pressing play at this point, that means you've already finished your halt and you're ready to go through it together. So let's get started. H is already filled in for us. Heading, table 1. Let's go through the variables. What are our variables in this case?
They're enzymes, rate of carbohydrate digestion,
Rate of carb digestion.
protein digestion, rate of protein,
Rate of
protein
digestion.
rate of lipid digestion,
Rate of lipid digestion. And
temperature,
last but not least,
pH.
boom. Outstanding. All right, a bunch of different things getting digested, some enzymes, temperature, pH, boom. Move on to units. There's actually only 2 different units that are used in here. What are the 2 units we're using today?
The units are microliters per second and Celsius.
Excellent. All right, for those of you at home wondering what the funny looking U is, all right, that is a Greek letter that is used to represent the word micro. All right, micro is very, very small. So a milliliter, ml, is small. A microliter, which is UL, is even smaller. All right, in order to find the amount of a microliter, you have to use a very specialized, essentially a very specialized eyedropper that costs like $400 to get out a microliter worth of substance. I'm not complaining with what I would do about it. All right, and last but not least, we have trends. All right, let's go through some of our trends. What's one trend? I'm not sure. Okay, we'll come back to you in a second. Anyone give us a trend?
As the rate of carbohydrate digestion increases, the rate of protein digestion.
Nice. For both enzymes?
Enzyme.
Let's see, for enzyme 1, protein carbs in there. So you're saying as carbohydrate digestion increases, you move down that way. And as you move in the same direction for proteins, the numbers actually get smaller. Nice. Perfect. All right. Do you have another one for us?
As the rate of protein decreases, the rate of lipid increases.
Increases and then does what? Nice, good. Right. You also notice you can make some sort of relationships with pH, right? pH increases. You could say something as protein digestion decreases, the temperature stays constant. Temperature, all sorts of fun shit. All right, let's jump into then Pac-Man. Again, take another 2 minutes or so, and you watch from this experiment, Pac-Man, what they did. Remember, the key should just be a quick summary, not everything they did, just a quick summary of what they did. When you're ready to go through the answer, press play. If you're pressing play at this point, it means you finish your Pac-Man and you're ready to go through the Pac-Man together. Again, Pac-Man is not something you necessarily do on the ACT, but it's a great skill to be able to do when you have a couple of minutes to think about the experiment. Reasonably practice on it during ACT practice time, maybe you can start to get some of these done in your head really quickly. Like what we're going to do is we're actually going to skip the P and go straight to the first A. Think about the purpose of this experiment. Anyone tell me why they did this experiment? What was the overall goal for this experiment? To determine the rate of digestion or consumption, either word you can use, for what? From enzymes, good. And what were they digesting? What were the substrates? Nice. Of our three substrates, carbohydrates, proteins and lipids, at different what? At different pH. Nice. At various pH. This is a lot. This is actually lots of experiments thrown into one experiment. All right, because you're changing tons of different things at different points. At one point, you're changing the enzyme, and then you're adding in changing the substrates, and then you're changing the pHs. All right, so it's kind of crazy to think about how they can do this. All right, so if we think about how this experiment would run, all right, and taking a look at our data, what did they do in order to get to this thing? What was roughly their procedure? Like if you were a person in a lab coat, you were in their lab, what would you have to do? All right, we can even take a look back at the passage between the two. A group of students were investigating the properties of two unidentified enzymes. What did they do?
Determine the substrate that will break down the enzyme.
Right. Yeah, they tried to figure out the substrate that would break down the fastest from the enzyme. So they labeled test tubes containing enzymes 1 and 2. All right, so you get a test tube. Hey, there's a test tube. What do you put in the test tube? Enzyme, which one? What do you want to start with? Okay. What else do you add to this test tube? All right, we'll start with carbs. And what else do you add? Now for this tube. Yeah, what you're changing here is the pH. All right, because the temperature should stay the same, so the temperature of this thing should be 37 degrees, just like all the other ones. And then what you're going to have is certain pH. What pH do you want to set this at? Great. And then you let it run. Let it digest. Carbohydrate breaks down. Use a big giant spectrometer, which is like a big giant box like this. You put a little container on the side of it. Take the test tube. Container, and then there's like lasers that blast the test tube, and it spits out this little reading, and it looks like this. And this is way more information than you need to know for the purpose of the lab. It's all right. They're really confusing to read, and then you get some information. You figure out what do you figure out from this reading of the machine. The spectrometer will tell you how much what. of no. So it tells you how much what, in this case, what's our substrate? Carbohydrate we decided to pick for the first one. It tells you how much carbohydrate is left. So what you can do then is figure out how fast it broke down the carbohydrate. All right, and that's how they did this experiment. However, they didn't just do it for this, because if we had enzyme 1, how many times did they allow enzyme 1 to break down carbohydrates? 4. Because they had enzyme 1 breaking down carbohydrates at how many different pHs? 3, 6, 8, 11. Now they didn't just do it with enzyme 1. I'm sorry, they didn't just do it with carbs. What else did they do it with? Proteins and lipids. So now we need to have at least 12 test tubes. So this is all enzyme 1, breaking down carbs, proteins, and lipids, all at different pHs. It was 3, 6, 9, and 11. 3, 6, 8, 11. But now they didn't just do this with enzyme 1. They did it with enzyme 2. All right, this is a massive experiment. All right, lots of test tubes, lots of trials, lots of different data. All right, but in the end, the important thing to take away from here is what did they measure? In the big table, what did they measure about each one? The spectrometer will tell you the concentration. All right. And so then what you can find from the concentration is the rate. You think of it this way. Think of digestion. All right. You like to eat pizza. Pizza. All right. You have a whole pizza to start with, which contains how many slices? 8. 8-slice piece of pizza. All right. In 16 minutes, there are no slices. So in 16 minutes, how many slices did you eat? 8. So then the question is, how many slices did you eat per minute? And what you're looking for with a specific unit would be slices per, which means we do a division sign, minute, which means you take your slices, and what do you do with that number? Divide by minutes. And you get slices per minute. And what would you get in this case if it's 8 over 16? 1 over 2, 1/2. Which means you are eating 0.5 slices per minute. Because you knew how much you started with, you knew how much you ended with, and you knew how long you had, and you can calculate what's called a rate of pizza eating. In this lab, did the same thing, except for instead of a rate of pizza eating, they did a rate of substrate digestion. So you knew how much protein you started with, you knew how much protein you ended with, and you set it for a certain amount of time, and you could find out how many microliters per second are being digested. Whoa. Yep. So you know how much you started with, you know how much you ended with because you used the spectrometer. You also knew how long you took because they kept everyone the same, which means you could divide how much went missing by the time and get a rate. So like you knew the starting ULs, you knew the ending ULs, just like we knew the starting number of slices and we knew the ending number of slices. And we subtracted those two numbers and you divided by time. So in this case it went from 8 slices to 0 slices, which means you eat 8 slices in 16 minutes. You do the same thing for this lab. You're just using microliters instead of pizza slices. So let's take a look at the practice problem. Look at all those. All right. Oh, let's take the practice problem. How fast does enzyme 2 digest carbohydrates at a pH of 8? All right. Practice this one in your team. When you're ready to go through the answers already given for us. How would we get this answer of 0.13? We're looking for how fast enzyme 2 digests carbohydrates in the H ring. All right, take a look at it. We're looking at enzyme 2, which means we only care about that. Which substrate are we looking at? Carbohydrates. So we only care about this row, which means right now we only care about this particular box section right here. And what else do we care about? pH of 8, right over here. So where do all of our boxes intersect? 0.03, and here's our speed, microliters per second. Ooh. How's that? All right, what you want to do right now is practice questions 1, 2, 3, and 4 together in your team. All right, on the back, so these are kind of practice questions about thinking about rates and driving. So we're going to go questions 1, 2, 3, and 4. The car driving question from the back. And when you're ready, press play and we'll go through the answers. All right, at this point, if you're pressing play, you're ready to go through the answers to some of these problems. So the most important thing to keep in mind on how to do these rate questions is always something about unit analysis. So essentially, you can figure out the formula you need to use by thinking about the units that you have at your disposal. What we mean by that is if we take a look at the first question, a car is driving at 30 miles per hour. How far will it travel after 3 hours? You essentially have 3 different things that you can figure out here. You have the speed of the car, which is 30 miles divided by hours, miles per hour. You have the total time that you take, which is 3 hours. And then the question is how far will it travel, which is, so it's a mystery number of miles. All right. If you have these 2 numbers, miles divided by h and an h, and you know you need to do something to get to m. What do you have to do with this variable and this variable in order to get to m? So just think about, like, in general algebra, how would you turn an m divided by h and an h into just m? Nuts. Because if you multiply these 2 together, m over h times h, remember this would be over 1, the h's would cancel, and all you're left with is m. So you do that same thing in this problem, where now you just have to fill in numbers. So our m over h was 30. Our h was 3. You multiply the 2 of those together, and you get 90. Okay, let's try that again with the next one. Jody eats 10 cookies per minute. So we have 10 c over f. How long will it take her to eat 40 cookies? We know that c is, there's 40 cookies that we're dealing with here. And what we don't know is the time. How long will it take her? Which means we have an unknown number of minutes. So we have a c over m and a c. How do we get an m out of that? Multiply them together? So if we multiply, if we took c over m times c, we would get c squared over m. So it's not multiplying. If we divide that, which one on top, which one on the bottom? So we take C divided by C over M. Which then is C times M over C. Just remember, when you divide, you're multiplying by the reciprocal. Will that get us our answer? Sure will, because the C's will cancel, and we're left with M's. All right, that's the algebra way to think about this. We could also use common sense. And so this, a car is driving at 30 miles per hour. That means in 1 hour, so this is back to the first one, in 1 hour, how many miles does it drive? 30. So how far would it drive in 3 hours? 90. All right. Jody eats 10 cookies per minute. All right, that's a lot of cookies. All right. In 1 minute, she'll eat 10, which means in 2 minutes, she'll eat how many? 20. In 3 minutes, she'll eat 30, which means how long will it take her to eat 40 cookies? 4 minutes. Two totally different ways to approach the same problem. Either just think about what the numbers mean, or you could do algebra. Whichever one you want to do. All right. The reason I show you these two simple examples is because they're the same exact thing as when we start using microliters per second. In this case, we're digesting something at a rate of 0.1 microliters per second. How many microliters would then be after 3 seconds? If we digest 0.1 per second, how many is after 3 seconds? What we need to do with those numbers? Multiply, yeah. So after 1 second, it would be 0.1. After 2 seconds, it would be 0.1 times 2, which is 0.2. And after 3 seconds, it would be 0.2. So after 3 seconds, it should be 0.2. Next one. Enzyme 2 digests lipids at a rate of 0.12 microliters per second. How long would it take then to digest 0.6 microliters? This is the same as Jody eating cookies. All right. After 1 second, how many would be digested in this case? If you're digesting 0.12 microliters per second, after 1 second, how many get digested? 0.12. Which means after 2 seconds, how many are digested? 0.24. Which means after 3 seconds, how many are digested? 0.36. Which means 4 seconds is what? Which means after 5 seconds, how many are digested? 0.66. So how many seconds did it take to get there? 5. All right. This is the kind of problem that you can overthink. Just because the units are weird doesn't make the question hard. All right. At this point, what you want to do is you want to pause the video and you want to go through questions 6 through 11. 6 through 11. When you are done going through questions 6 through 11, press play and we'll go through the answers together. All right, if you are pressing play at this point, that means you are ready to go through the answers for these questions. We take a look then at question number 6. It says, according to table 1, what is the rate of lipid digestion for enzyme 1 at a pH of 6? 3 important words here. I always suggest underlining them. Lipid, enzyme 1, pH 6. So here we go. We need lipid and here. Enzyme 1 in here. pH of 6 right here. Which means that right there. Which is answer B. No. Alright, based on table 1, at what pH could enzyme 1 digest proteins at a rate of 0.1 microliters per second? Alright, now instead of looking for a rate, we're looking for a pH. We still know the enzyme, we still know the substrate, and now we know the rate. So now we're looking for enzyme 1. We're looking at a pH, a mystery pH. We're looking at proteins, somewhere in here. And we're looking for 0.1, which is right here. The pH is 11. Delta, yeah.